Hello and good afternoon. This is Bob Forche, Supply Chain Pro to Know, and today we're going to talk about order quantities and cost varying according to order size. But we're going to go beyond the traditional conversation, which looks at just carry cost and order cost. So today, to introduce myself, you can see I have a number of industries here represented. I've been independent consultant and trainer since 2007. I was on the faculty for university teaching supply chain and advanced manufacturing for several years and helping consulting and training employees for various different industries. You can see a wide range of topics here. So the benefit there is I have a lot of exposure to different environments and different needs, which has been very helpful for my business. For you today, my promise is to provide you some value, something that you can use immediately right in your business. The problem statement is simple. What about inventory cost that impacts cash flow and profitability in a negative way? It's going to show up in the COGS, cost of goods sold, and we can have other factors that show up as well, not the least of which is maybe space utilization, overloading in the stockroom. It could be the fact that we have products that have a lot of changes frequently, so larger order quantities can be very problematic around that too. But our focus is primarily on cost for this conversation. The proof that we want to provide is a methodology to know your numbers. We really want you to have a more complete picture when you're making decisions about how much to order at any one time, what's the least total cost. And so we're going to give you a tool and some discussion here to have you set up a plan so you can approach this in a more systematic way. The action item here is to follow up, see what will help you, and offer your support if you find that you have questions afterwards. So let's get started here. Why do we care about order size? Well, let's take a look at a couple of situations and compare what this means in terms of inventory, order quantity, and average inventory. If you look at this data, we can break down a very simple example, 10,000 total units per year. If we had one order and it was delivered all at once, we would have an average of about 5,000 units. That's a lot. That means it takes a long time to use it all up, and at the end of the year, we would need to restock and start over again. In contrast, the quarterly example would be 2,500 units, which means every quarter we would get a restock, and that would result in something around 1,350 in terms of average inventory. Now, if we break it down to monthly pictures, then we have an 833 number, and our average is about 560. And if we take it all the way down to weekly averages, we have about 192 units per week. And assuming we are going to use up that on a weekly quantity, then we're going to start and end with zero. So arithmetically, we get a zero average. In practicality speaking, we've got some safety stocks and we've got some things coming early and things coming late. So the average is going to differ. But from an arithmetic standpoint, now we have a clear understanding about what different intervals are going to mean in terms of averaging. So let's put that into a graph here that looks at EOQ, economic order quantity. The concept is to find the least total cost or the theoretical optimal order quantity based on EOQ calculation. You can see here the carry cost goes up directly with the size of the order quantity because inventory is a larger quantity on hand for a longer period of time, resulting in a higher average inventory. And again, this is average, not ending inventory. So average over time. As we have a larger order quantity, we're going to order fewer times, so the order cost will go down. When you add these two parts together, we get the total cost, and our goal is to find the least total cost. So in this case, that would end up being an order quantity of about 400, which is the smallest least total cost. Now, how do we arrive at that? Here's a couple of examples using the formula for EOQ. Notice it's 2 times the annual usage times the cost per placing an order divided by the carry cost rate times the cost of the unit, and then divide that by the square root, and then we get the in this case, the quantity of 400. You'll also notice on the right-hand side here how that total cost of 800 goes up no matter if you go smaller or larger, because in either case, one is going to increase the carry cost or the order cost. So our goal is to find the least total cost and really zero in on that. Well, what makes up carry cost and order cost? Here we can see several different factors. We're going to look at the top three primarily today. If you have a stock out, obviously there's cost of lost sales, so that could be a factor in terms of revenue. And capacity related would be something that to pay attention to in terms of production. We're not going to focus on that today. We do want to think in terms of purchasing, and then we'll look at the top three: item cost, carry cost, and ordering cost. Item typically is where we see the cost of transportation and or tariff. And you don't see tariff listed here because that's separate. Actually, there could be a couple of different tariff rates that you might need to pay attention to, and each different supplier source is going to have different rates depending on what your commodity is. The interesting thing about this is that transportation has sometimes a fixed unit cost, but it also has some variable costs related to how many deliveries you're going to have. Is it a full container or less than full container? And some other factors that might be needed to be included based on LCL. If we look at ordering cost and carry cost a little deeper, we see that it's made up by capital cost, storage, and risk. The interesting thing here is on the lower right hand of this slide, focus on the carry cost. Here it adds up to be 24%, 0.24. And if you had an average inventory of 3 million, this would result in a carry cost of $720,000 per year additional to the cost of the item. And a lot of people don't key on this right away. You pay for the item, but you also pay for having it, for owning it, for storing it, for transacting it, for dealing with risk and obsolescence and damage and all those other things. It's a real cost. So obviously the opportunity here is to find ways to reduce the carry cost, but not in a negative way. So we want to understand how we can do that. Ordering cost is very straightforward: the cost of the organization and operating expenses, and then you've got the number of orders per year, and then you might have some additional setup, which could be a manufacturing setup or it could be a transportation cost related to getting a shipment done. So if we put these two together, then the question is, what's the least total cost? Well, if we only look at this data, it's incomplete information. It's not showing us the whole picture because we don't have all the transportation costs. And you see this because when you make a purchase order in your ERP system, your PO typically is the unit cost, and maybe there are some surcharges on there, but where your import costs and your transportation costs tend to show up in other categories. Inbound freight, for example, and that doesn't land in the PO. So it doesn't always find its way to the item cost. So we have to look elsewhere to get the other data. We also have to pay attention to the cost of cash and the time it takes to replenish our cash. So this is a function of payables, receivables, and average inventory again. What this really means is that when we spend some money, it's going to take a while to get paid by the customer and then allow us to reinvest that dollar to buy more inventory. So we have to pay a lot of attention to how long it takes that process to happen. So let's break that down with an example. Here you can see an example of a 90 days average inventory and 45 days receivables with 30 days payables. When you add these together, the sum is 105 days cash to cash, which means when you invest $1 today, it's 105 days on average before that dollar is going to come back and be available to be invested again. This is going to show up as your cost of inventory, your cost to carry, and your cost to order, all parts of that COGS number that you have. And then when you factor in the time factor, this is where that is going to make a bigger difference. The way to reduce the impact is to have a lower average inventory. So this is where we see the bottom example here. If we were able to cut this inventory in half, not a small feat, but definitely the target, 45 days of inventory plus 30 days receivables and 45 days payables, now we are at a 30-day cash to cash cycle, which basically says we have cash coming in, recycling every 30 days, which means we no longer have that extra cost of financing to borrow on short-term operational coverage. So then we add in the other conversations around containers cost, transportation costs, and tariff costs. Now the tariff is going to be a fixed unit price plus a percentage of the cost of the item times the volume. So that's a variable number. And then we've got a variable number in terms of the transportation piece as well. If we look at LCL, less than full container, smaller order quantities typically are going to cost more because you're not using the whole container. So the cost per unit is likely to go up, but your inventory on the average is going to be smaller and you're probably going to save carry cost. On the full container, it's just the opposite. So now we are going to order full containers, and that means we're going to have a lower per unit shipping cost, but we're going to have a higher average inventory and more carry cost that offsets that other savings. So we have to be careful about that. So what do we do? Well, let's look at an analysis tool here. And at this point, I want to open up the worksheet I have. And we'll talk a little bit about what we see here. Tab 1 is some instructions. This is for you to look at later. I'm not going to spend time on that, but we can go right to the data. In this worksheet, all the blue cells here are areas where you can populate your data and do some analysis. So in this example, we see you have 12,000 units a year, $10 per unit in terms of the purchase price, and then we see some tariff information, we see some freight information, we see holding costs, carry cost is 25%, and we see what's the cost per shipment and per container. We also see that in this particular case, the container can carry 2,500 maximum. And we see lead time. Now there's 2 lead time here, which is not uncommon because LCL often means there has to be some consolidation, and that can add some additional lead time to find other materials to go into that container, unless you want to pay for an exclusive container, which is going to cost you more. The bottom line here is your landed cost now is going to be $12.30 per unit, and we get a couple of different calculations here. The EOQ based on LCL, so a smaller order quantity, which is going to be offset by more transportation, or the EOQ if we're using full container loads. So let's look at how that breaks out. And this is the second tab. Now notice in here, as it brings over the data from the blue cells in the first tab, we see the purchase spend 147.6. And then we look at the LCL, you can see where we run across our total cost here is 168, which includes all the holding costs and all the freight costs. Now, what happens as you increase order quantities? Well, let's go down to the next row. So in this case, it's a full container, 2,500. So that means you're going to need more than one delivery per year. And we see what happens in terms of order quantity going up. So in this case, we see the holding costs increasing, and we see how that increases as it goes. It fluctuates a little bit here, but then it starts to go up again. When you start to go past the 12,000 number, it starts to increase carry costs a little bit more. So this is where we might want to do some analysis. So let's take another example. So let's plug in a different number here. Let's say our demand is 5,000 per year. And let's say our unit price is $190 each. Let's say we have a unit, the schedule is 30 cents a unit, but then the percentage rate, let's say it's coming from Vietnam and it's 47%. We got 25% carry cost, and let's put in a container cost. Let's say an LCL could be 6,000 and a full container might be 5,000. We're just making up numbers here, all right? Notice what happens to the EOQ numbers. So quite a bit different now. So what happens here when we start plugging these values in? I bring in one container, 2,500, we see 155.8. If we see the LCL, so it's got a quantity of about 925 and about 1,000,005. So it's very, very close in this case. So an LCL versus one container full. And because our demand is 5,000 a year, it wouldn't make a lot of sense to bring in more, because notice right away, if we do 2 containers and bring in 5,000 once a year, then our carry cost is going to go up right away. We see about 100,000 increase. Remember, that's cost that drops right to the bottom line. So this is where we want to really understand the cost of that carry cost and the least total cost. So that's the quick summary here, how to use this worksheet. You want to plug in the values that you would use based on your products and your transportation. Now there's another tab I'll talk briefly about here. This is EPQ. I added this because sometimes we want to understand what's going on in the manufacturing process. There could be some batching that might happen if it's a process flow industry, like petrochemical or pharmaceutical or something like that, food processing. It might well be a batch process, not discrete manufacturing like cell phones or circuit cards. So in this case, we have another view here, how we might want to consider batches based on the process flow environment. So I included that here. It's just an extra thing for you to enjoy. So that's the summary then in terms of the worksheet to do some economic order quantity evaluation. Now let me jump out of there for a moment and go back here. I just want to say a couple of things. If you want some help to do some analysis, you can text me or email me. So text right here. I would love to be able to have the opportunity to chat about your conversations. What are your needs? What are your challenges? We can talk a little bit more about what makes sense there. And you can easily reach me there. That's my office number, and I'm on WhatsApp as well. And here's my email for direct communication as well. So Supply Chain Pro to know, to help you with your inventory planning and hopefully reduce your COGS to make yourself a little more profitable. Now, any questions, you can reach me through the email or through the phone. I'm happy to spend a few minutes time on you. We can do a Zoom call or a phone call and follow up and see what would be some additional value to help you with. So that's what I have for you today. Again, Bob Forche, Supply Chain Pro to know. Let me know if there's anything that would be important to do a follow-up on. Thank you for your time.